Hey everyone, and welcome. Today, we're jumping right into the heart of the data world to look at a huge clash of ideas. On one side, you've got the super organized, predictable world of order, and on the other, the kind of chaotic but super adaptable world of flexibility. And trust me, this isn't just some nerdy technical debate. It's a battle of philosophies that literally shapes the internet we use every single day.
So it all really boils down to this one simple question. With all the amazing tech we have, why can't we just build one database that's perfect for everything? You know, a one-size-fits-all solution. Why do we need so many different ways of doing things?
Well, it's because you've got these two powerful, opposing forces pulling in different directions. On one team, you have order. This is all about structure, consistency, and making sure everything is 100% correct all the time. But on the other team, you've got flexibility. This is about handling massive scale, constant change, and data that's, well, completely unpredictable. So let's see how this whole conflict got started.
All right, to get this, we've got to turn back the clock a little bit, to a time when one model for handling data was completely dominant. For decades, the relational database, you'll hear it called RDBMS, was the undisputed king of the castle. Think of it like a perfectly organized digital filing cabinet or a giant spreadsheet. Everything had its own specific drawer, a defined structure, and a clear relationship to everything else. These systems were mature, rock-solid, and super dependable. But what happens when that perfectly orderly system runs headfirst into an explosion of pure chaos? Well, the age of structure was about to get a serious reality check.
And that chaos, it was the modern internet. All of a sudden, we weren't just storing neat rows of customer names and addresses anymore. We had social media posts, photos, likes, clicks, system logs, a massive, messy, and insanely fast-growing tsunami of information that we call big data. And those old structured filing cabinets, they just weren't built to handle that kind of crazy volume or variety.
And this really gets to the heart of the problem. To handle more data, the old relational model had to scale up. That meant you had to throw money at the problem by buying one single, bigger, more powerful, and ridiculously expensive server. The new way of thinking was to scale out. Just spread the work across a whole bunch of cheap, off-the-shelf computers. It was a totally different and way more affordable way to grow. So, this need to scale out didn't just lead to a new product. It sparked a full-blown revolution. It wasn't about building a better database. It was about inventing a completely new philosophy for how to think about data. And that's where NoSQL comes in. Now, NoSQL isn't one single thing. It's a whole category of databases, a movement, really. And they were all built from the ground up to be distributed across tons of servers, to handle insane amounts of information, and to work with a really loose, flexible structure, or sometimes no predefined structure at all. And this is the key. It was a philosophical shift. The old relational databases lived by these super strict rules called ACID. That's atomicity, consistency, isolation, and durability. It was all about guaranteeing that every single transaction was perfect. NoSQL systems, on the other hand, embraced this new idea called base. Basically available, soft state, and eventually consistent. They basically traded that guarantee of perfect, immediate consistency for massive availability and the ability to catch up later, to be eventually consistent, which it turns out is exactly what you need for a giant, global, distributed system. But of course, this new power came with a price. There's a catch. Every distributed system, and that includes every NoSQL database out there, is governed by this fundamental, unavoidable trade-off. It's called the CAP theorem, first figured out by Eric Brewer way back in 2001. And you can think of it like a law of physics for data that's spread out across the world. It says you can have three really good things, but you can only ever pick two of them at the same time.
So what are the three options on the menu? First up is consistency. This means that everybody who looks at the database sees the exact same, most up-to-date data. No exceptions. Second is availability. This just means the database is always online and always gives you an answer when you ask it for something. And third, you've got partition tolerance. This is a big one. It means the system keeps on chugging along even if some of its servers can't talk to each other because of, say, a network failure.
Now, here's where it gets really interesting. In any modern system that's spread out over the internet, network failures are just a fact of life. They're going to happen. So that P, partition tolerance, is not really optional. You have to pick it. That means the real choice, the big trade-off, is between consistency and availability. Do you build an AP system or a CP system? An AP system chooses availability and partition tolerance. This is perfect for something like a social media feed. If I see 100 likes on a post and you see 99 for a few seconds, who cares? The most important thing is that the site is always up. But a CP system, that's consistency and partition tolerance, is what a bank would use. They would much rather shut down for a moment than risk showing you the wrong account balance. They choose being correct over being available 100% of the time.
Okay, so this is all pretty theoretical, right? Let's make it real. Let's take a look at how this all plays out in one of the most popular NoSQL databases in the world, MongoDB.
So this is MongoDB. It was developed by a company originally called Tengen, and it's a prime example of what's called a document-oriented NoSQL database. Instead of storing data in neat tables and rows, it stores information in these flexible, JSON-like things called documents.
So, faced with that impossible choice from the CAP theorem, which two did MongoDB pick? Well, it chose to be a CP system, prioritizing consistency and partition tolerance. This means MongoDB makes a promise. If there's a network problem and it can't be sure the data is correct, it will choose to be correct over being available. Just like that banking system we talked about, it will stop responding if it can't guarantee consistency.
And to help you wrap your head around this new world, here's a quick little translation guide. What the old relational database is called a table, MongoDB calls a collection. A row of data becomes a document, a column is now a field, and that idea of scaling out by splitting the data across servers, in the Mongo world, that's called a shard.
But maybe its most famous, its killer feature, is being schema-free. And this is really the heart of its flexibility. It means you don't have to define the exact structure of your data before you put it in. Every single entry, every document, can be totally different from the one right next to it.
And this is just a perfect example of what that actually means. Just look at this. The document for Jeff has his location and his boss. Brendan's document has a list of aliases, Ben's just says he has a hat, and Matt's document tracks his pizza preference and his height. All of these completely different structures can live together, side by side, in the exact same collection. This is something that would be absolutely impossible in a traditional structured database.
So, this brings us all the way back to the final trade-off. We've got two powerful, but very, very different philosophies for how to manage the world's information. On one side, you have the structured world of RDBMS. It's mature, you've got great vendor support, and it's amazing at letting you ask complex, on-the-fly questions of your data. On the other side, you have the flexible world of NoSQL. It's built for massive, elastic scaling on cheap hardware, and its data model is incredibly adaptable. So you see, there's no single best answer here. There's only the right choice for the specific problem you're trying to solve.
And that leaves us with one last thing to think about. The web, the apps on our phones, pretty much our entire digital lives. They're all built on top of databases like these. So now that you understand this fundamental trade-off between order and flexibility, which world would you choose to build your next big idea on?